The MTDCNC Podcast, sponsored by Langley Alloys, unique metals for demanding applications, providing first-class performance and an international service.
Hello, welcome to another MTDCNC Podcast. Our podcasts are sponsored by Langley Alloys. In today's episode, I'm here at Sodi-Tech's headquarters in Warwick, and I'm with Conor Plaskitt, and we're going to be talking about the machine that is behind me here. If you can see it, if you're watching, it's a UX 450 high-speed machining centre from Sodick. And now you may be listening to this on whatever platform you choose to listen to your podcast, or you may be watching on YouTube. Either way, we've got something very special coming up here, a real education in what you can achieve when it comes to high-speed machining, high-tolerance machining, and amazing surface finishes. Now, I would encourage you, if you are listening, to actually go to YouTube and watch this, because you will be able to see the types of finishes and the types of applications that can be machined on the machine that we're going to be talking about. But before we start, Conor, perhaps you could just introduce yourself to our audience and why you're the person I'm talking to about this on this podcast.
Yeah, so, I'm a technical sales manager for Sodi-Tech in the UK and Ireland, and prior to that, I've done many applications, spent lots of years in applications and tool making as well. So I've got a good broad understanding of the industry. Okay,
now with every machining process and every machine tool we talk about, Sodi-Tech and Sodick are very well known for your EDM, your wire, your spark solutions,
That's right,
and of course injection moulding.
Correct,
we can't forget that. You've got an amazing headquarters here, which I think opened in about 2019. Where you've got a lot of the machines that are available within your range. And when you come here, it really is extremely impressive. So congratulations on that, because I know you're part of the team that operate from here. But with every single one of the machines that you supply, and today we're specifically talking about high-speed milling and high-speed machining, warrant an application. They've got to solve a problem. The machine we're talking about here, can you explain, or can you tell us what it is, and then tell us what the applications are that this is perfect for?
Yeah, so the UX predominantly, as you've already said, it's a high-speed milling machine. So we're really going for sort of the highest level work that you can achieve. So, every machine has got its place in the market, and this is really after that top tier sort of work. So any sort of high-end medical moulding applications, very accurate electrode manufacture, as well as some jig grinding applications as well. This is the sort of machine for that job.
Now, the first thing I want to do is identify with those topics really in the applications, because I want to try and establish how what the broadness of its market. So we're talking about mould tools, great surface finishes on these mould tools. In the UK alone, how big is that sector for you, and where this machine would fit?
I mean, really.
And what are the industries?
Yeah, I mean, the industries, a lot of it can be sort of, like I say, general medical moulding, especially in Ireland as well. That's a big thing. More the UK side could just be a lot of automotive moulding parts, which is an example that's there on the table in front of us. As well as sort of all general sort of moulding processes that tie in really with machining and EDM machines.
And then you talk about fine detail machining. Give us an example so I can get a picture in my head of something that's got really great detail on it.
If we've got anything, let's say, lots of tight corners, lots of facets, like, I keep referring back to that part that's sat in front of us, something that would be difficult to polish by hand. So if you're a bench hand and you've got to get in there and you've got to, finally lap out a finish, potentially you could be losing some detail in the end product when you come to moulding. So really, this is where this sort of machining centre takes a lot of that manual process out and gives you a high-end quality product.
And then you talk about electrode manufacture.
Yeah, so as we're well known for our EDM machines as well, really 95% of your sparking process is down to the electrode that you've manufactured and produced. So if you're going again for real high tolerance cavities, you need to make a good, well toleranced electrode to be able to achieve that. So again, this is where that sort of machine sits in the market.
I mean, taking two of the examples that you mentioned, mould tools and electrodes, there are machines in the marketplace that are making those that are nowhere near as capable as what we've got here. So you don't have to have a machine like this, or there's opportunity
that's it.
for other machines too. Just
Indeed, yeah, exactly.
the
So,
lines for
like I
you.
say, all the machines have got the place in the market, really. It all depends on what you're moulding. So, when you're talking sort of general use, sort of everyday sort of moulding plastics, 10, 15 microns tolerance on a cavity, more than good enough. When we're talking sort of high-end medical moulding applications, where we're using lots of rubber, lots of silicone, the flash point is a lot less on that, and that's where shutout is important. Really 2 and 3 microns can make the difference there.
So this would be essentially, the male and female tool, making sure that the match is as perfect as possible.
Correct, yeah. And if you haven't got that, you're getting lots of flash on parts, and you're getting lots of scrap parts that are no good. And especially in the medical sector, that's very important.
There was also another area we spoke about jig boring. Something that is
an old sort of dying process now, really, with the old real manual old big jig borers, which again, good old machines like that could easily hold 2 to 3 micron tolerance to a skilled operator. This is again where this sort of machine sits. So we can accurately, this is a sort of a sub 3 micron machine in a good environment. So really any high-end applications like jig boring, for example, this is perfect.
And now with jig boring, the clue's in the name, boring, but here you're interpolating steel.
We're interpolating
extremely tight tolerances.
Correct, yeah. So I mean the accuracy of this machine, I said, is sub 3 micron. So yeah, any real high tolerance holes where roundness and straightness is absolutely key, then this is something we can do.
I mean, your EDM's machines are positioned at the premium end within the marketplace. You're putting them into very high-end industries, and also we can't forget that, and you'll see a lot across MTD, end users that maybe just want that reliability and that that assurance of what you've got here in Warwick to support them. This, as a family, kind of fits in that area as well, then, doesn't it? It
fits perfectly alongside our other product range. So, if you look at all our EDM machines, all our wire cut machines, they, like you rightly say, they all sit at that high end of the pyramid in terms of machine tools capability. And again, this is where the UX fits into that range as well.
Okay, so how does it achieve all of what we talk about? Because some of the points you make are, from me, I look at it and go, wow, that's quite something to be able to achieve these things. What have you got on the machine? How is it made? What are these points?
I mean, we're very well known, one, for our linear motors. So this is something that we've pioneered for the last sort of 25 years now, I think, almost, since about 99 was the first linear machine in the UK. So again, we're on 8th generation linear, so we've constantly sort of developed and advanced that process.
And where are these linear
motors
on this
so
machine?
On this particular milling machine, that's in all axis, so that's X, Y and Z.
And it's important to state at this point that most machining centres run using ball screws, don't they?
They do, which depending on your application, again, there can be advantages and disadvantages. Really with this machine, we're sort of high feed, high speed and low torque applications.
What about the maintenance of things like linear motors
again,
as well, then?
Linear motor, there's no moving parts. So you've not got two mechanical items that are, pushing and pulling against each other, which in turn, in time, will give you backlash, will give you wear, will give you problems with tolerance.
Well, what have you got then? What is a linear motor?
Linear motor is basically, you've got a flat rigid magnet and then you've got a coil that sits on the carriage of the machine, and that's all it is. So it magnetises, and we can just tell it to move to a position. So we're using a Heidenhain glass scale. So that's giving us our position, and then all we're doing is energising the magnet to move that axis backwards and forwards.
Okay, so your positioning is coming from...
Yeah, so we closed loop Heidenhain scales. So in terms of positional accuracy, we're going to be on this machine, we're working to 5 decimal places in resolution, and then positional accuracy and repeatability within 3 microns. And
the speed that you talk about, is that an important factor in the things like the surface finishes?
It is, yeah. So for example, the part that I've referred to anyway, we're talking that's 2 micron step over, but very high feed rate, and we're running the spindle up at 40,000 RPM.
Okay, so if you are watching this on YouTube or on the MTDCNC website, you will be able to see this part that we're talking about. If you're not and you're listening, then I would encourage you to when you finish listening, to have a look at this particular component, because this is, as a surface finish, it's like a mirror.
Oh yeah, it's as near as you can probably get to a mirror. So that is actually below 0.1 RA, so that's measured at 0.008. So, right. I mean, to polish that by hand, you're going to be there for a very long time. Right,
so how, I know it's an example part, and we'll come back onto the machine and the other points of its build which enable it to be able to produce something like this. But how would you go about, well, tell me about the times and the speeds, which you have mentioned already, but say them again, as to how you go about making that and achieving what you've got here.
Yeah, so I mean, that, in example, that's a hardened piece of Stavax. So we're talking between 54 and 56 Rockwell. So that's been machined from solid as hard material, so it's not been sent off for heat treatment. You know, that's come in as a hard block, machined all on the milling machine. Again, you know, we use a series of cutting tools, so we've rough, we've semi-finished. So really that process is quite quick in terms of that size of component there. That's 25 mil square by roughly 20 mil in height. The roughing side of it was about 2 hours. But then the times in the finishing, you know, 2 micron step over with that cutter going around it, you're talking nearly 9 hours in polishing time. But again, that's the machine that's running. It's not somebody standing there, you know, a bench hand over the tool.
And why is the time though, Conor? I mean, that does sound like a lot of time, and I know
it does.
I know you're going to justify that in the points you make, but
in terms of, again, hand polishing it, if you were to take that part, for example, lots of very small facets, lots of tight radiuses on it. If you were to hand polish that, you would not be able to keep the form accuracy. So by doing it on the machine, you know that you're going to get a very accurate component that's coming off that you're going to be able to mould with straight away.
And why is that finish so important to a mould?
It depends really on the finish you want on your plastic. Some stuff they like a rough finish, so generally EDM it, leave a bit of more of a coarser finish on. If you want a very good sort of, say a shiny surface on your plastic, then that's when you go for a high polish on your mould. And again, depends on the material in the application. So
this tool here, and again, I say it again, if you are
not
watching, you should go onto YouTube or our website and watch this. What size is this, and is this the finishing tool?
Yeah, so that is the finishing tool. So that's it's a 2 mil ball nose in effect, unfluted tool with a diamond tip. So we've left roughly 30 microns in for finishing, and then that's just gone round and finished that form. Okay. So roughly 9 hours on that.
Okay, so we spoke about the application, we spoke about linear motors. We'll come back to the to the build of the machine. There was something to do with, is it 7 tons? This machine?
So you'll notice
the construction is
for a small machine as it is. There's a lot of weight in that casting.
Where is that weight? Is it all in the
It's all in the castings, yeah. So that's upper and lower. So really, it's been able to design and have a very rigid machine, which again, in terms, you're not going to suffer any harmonic vibration from outside the machine environment. You're going to be able to maintain stability and get repeatable parts off.
So you say 2-piece then? Is it a 2-piece casting? Is what we can see where we've got
it's a gantry style in terms of the table's going to move on the carriage front to back, and the heads will move left and right on the top.
And 2G acceleration,
yeah,
thanks
up
to
to 2G axis acceleration, so we can move that round and stop it very quickly.
And is one of the, I suppose, the ingredients to high speed machining is that point to point, isn't it? Getting it to move.
It is. It's being able to get it left and right, front to back accurately, and you know, again, being able to stop and start the axis as fast as possible, and that's only really something you can do with linear motors.
And is the fact that the table is centric in the centre of the machine,
it is.
Is that part of your design?
It is. It's all part of keeping it sort of balanced in effect. So being able to keep the machine balanced, so it's not moving around, it's not suffering from its own force of movement, that it stays rigid, and that we get very accurate parts off the machine.
What about things like the measurement of these parts and the tools? all of these things are really critical in amongst your manufacturing process, aren't they?
They are,
To be able to adjust according to tool life and tool wear. What are you using? Because to measure something like that.
Yeah, correct. So I mean, this machine is very comfortable going down to sort of 0.3, 0.2 and even 0.1 cutting tools, which on sort of most machines out there in the wider manufacturing world would generally struggle with, and that's not just down to the machine itself, but it's down to your spindle speed, but also tool measurement. So this particular machine, we use a vision system, so we use actually a camera system. One of the benefits of that is that you can accurately measure the form and the size of the cutter without relying on a beam, for example. So if we took a typical laser measurement system, generally the spot diameter is around 0.6. So when you get sort of 0.3 and below, you really start to struggle to maintain, accuracy in measuring those cutting tools. And we could only be talking maybe 5-6 microns. When you've got a 0.1 cutter and you step over and step down, is probably only 2 microns at maximum. Could be the difference between running all night long and breaking your cutter on the first time it touches the metal.
Yeah, I mean that would be one of the major challenges, I guess, with machining parts of this of the tolerances you're trying to chase, is maintaining a stable process within it, isn't it?
Correct, yeah.
So that's really what you've identified as the best way from a measurement perspective to ensure your tool is correct to carry out the process. Yeah. What about things like cutting fluids, swarf? I mean, you're not going to really need some of these things that you would look for in other machines.
Yeah, what you probably look for on your sort of conventional milling machine, especially with swarf management systems and stuff, swarf conveyors, we're not really generating on here massive amounts of swarf that we're going to have to handle, because it's all about, like I say, it's a high speed application, so we're not slogging millimetres of material off in passes. We're taking very small cuts at very high feed and high speed rates. So yeah, your swarf generally we're going to be dealing with more of a sharp, needly sort of fine powder and big bits of material.
What about coolants?
Coolants.
High pressure coolant. Do you need those things within the process?
Not necessarily. I mean, we have nozzle coolant on there as well on the cutting tool. We also have the option of mist cutting as well, and we just have a flood bed. So we tend to use oil-based cutting coolant on here. Again, that just allows us to achieve that higher surface finish.
And then the cam, what you're using to create the programs for these. Are you doing it here on this control?
Not necessarily on the control. So it's all ISO-based control programming format. But yeah, I use Power Mill, for example, but other cam systems are available and and able to post out to this control.
But you need quite a lot of memory, a high speed capability from the control.
You do. I mean, you can imagine with especially with some of your large components, the amount of lines of code that can be involved with such small step overs. So for example, we've just done a job recently, I think there was something like 130 million lines across the whole program.
Wow.
So being able to process all that in one, you need a good memory capacity, and that's exactly what we've got.
Overall, Conor, this UX range then, the UX 450, is this the only one in the family?
No, there will be a bigger one available. So it will be going to the UX 650, I believe, which will be the again the replacement for the previous UH series of machines. And then along the line in the future, there will be a 5-axis machine coming as well.
One of the things you have thought of here as well, I think from the operator's perspective, I noticed this because we looked at this machine at Mac as well, is the accessibility from the front and the side too.
There is.
Why did you introduce that side door? And what's
we introduced that side loading because it makes the machine more automation ready. So if you wanted to put this in a cell, say alongside a die sinker, so if you were using this as a electro manufacturing machine, basically, we would be able to take it straight out into a robot and then ready for the Sparker roller.
Is that something you think you would encounter?
Yeah, I mean, it has been done. We've already done it in the UK.
So someone's machining their electrodes.
Correct.
Robots coming in, taking the electrode off, putting it straight into the machine, the die sink machine, and then
producing components. So I think, and moving forward over the next 5 or 10 years, I think this is something that's going to become much more commonplace. Even not just in your higher blue chips, but all the way down the chain really. Because, skills are getting less and less. People really want to eke the most out of what they've got. It's sort of the way to go forward.
So the big wins really on this machine is removing some of the processes that would be done in normally, 2-step, 3-step product production basis. You're basically now down to less.
You're using the machine, you're utilising the machine's capability to replace, some of what is a dying trade really. But not only that, to produce high quality components that really, up until say maybe the last 10, 15 years, hasn't been possible.
Coming here to Warwick, people can come and witness this machine in action, see it producing parts like we've got here, I guess, and also maybe running some test pieces. Is there things you can show them to say, look, we were making it like this, how quickly can
it. Chuck as a test cut, chuck as a drawing, we're happy to do it.
Yeah, great stuff. Conor, it's been fantastic to speak to you. I know we saw this machine at Mac, and I know we only had a few minutes really to discuss it then. I think what is important with some of these podcasts is really to dig into the detail about the applications that they support. So to hear about the mold tools, the parts with fine detail, and also the jig boring element and the electrodes, I think that really shows our audience the type of market where this machine can benefit. And for those people also that would have normally maybe pigeonholed you because you're so successful with your EDM machines, hopefully this will give some visibility to the milling side, because it really is worthy of it. And I thank you so much for your time today.
Thank you, Paul.
Thank you. That's it for another MTD podcast. Our MTD podcasts are sponsored, of course, by Langley Alloys. Be sure to subscribe to them. We release a new podcast every week, and that's it from me now here at Sodi-Tech in Warwick.
Thank you for listening to this episode of the MTDCNC Podcast, sponsored by Langley Alloys, specialists in a wide range of exotic materials for any application for all your engineering needs.